Hey there, folks. We have a treat for you today. We have been challenged by a group of game developers. They are pretty far along in their game, and it's a multiplayer game. It's all about having a great time, and it's kind of physics-based, and each one of their physics-based characters is multi-part. Like, it's got 12 different parts of its body that they need to have the position and the rotation synchronized. And their current networking library that they chose, that they're going to go out to production with initially because they're so far along, is I'll not name it, right? Okay, I'm not going to put its name out there, but it's definitely something that if you go to the Unity Asset Store and you want to do networking, a lot of people are very familiar with this package, but it has its limits. So this particular team said, hey, GONet folks, we're currently limited by this networking multiplayer library, and we can only do 8 players concurrently, 8 players in a single multiplayer session. And they're like, we want to go up to 100 or even 200, and we want to know if GONet can handle it. So I took on that challenge. I thought it was really neat. So this is kind of a proof of concept, work in progress type of deal. I've had to turn a couple of things off within GONet, but they're not vital. It allowed me to crank up the performance a little bit, and I wanted to share that with you. So in the upper left here, I've got my server already started from the build, and as soon as the server starts, he spawns 5 characters, and you can see the user interface up there lists out how many positions and how many rotations are being synchronized right now with GONet. And then the target FPS is 60, and we can see how that may change as we ramp up and add clients and add a bunch more characters into this mix. So that's what I'm going to do. I'm going to spawn up a couple of clients so you can see them up here. So as soon as they come in, they have 5 characters as well. But that's not because they spawned their own 5. That's because these are the ones that were already spawned by the server. So I'm just going to get my other client in there that I wanted. Okay, cool. So I also opened up the task manager down there so you can kind of see where we're at on certain things. This is not a beefy machine by any means. It's 12 logical cores, and you'll notice that this is a very CPU-bound test that we're doing. And normally, you're only going to have one server or one client running on any given machine, but I just wanted to show you that even with all this stuff that we're going to add in, this machine, which is not top of the line by any means, it's not a gamer PC, not really, it's still able to handle it. So, and GONet can handle all this throughput. All right, so I'm going to go down here to this guy, and if I hit Alt Spacebar, he just spawned 5 of his own little dudes. And you can see in the other 2 windows, including the server and that other client, that they have also recognized the spawn, and they've got all these dudes being simulated, right? So if I spawn them, I own them. So I'm just going to go to the other client, spawns 5 there. He's got 5 of his. Everybody else sees them. And I'm just going to go back and forth between these 2, and I'm going to zoom out a little bit and just keep going back and forth and spawning 5 each. I'm up here again, and I'm going to go back here. I'm down here. It's 5 more. I'm up here, 5 more. And you can see every time I do it, the server is recognizing those spawns as well. I'm up here, 5 more. Okay, down here, 5 more. 5 more up there. Down here, 5 more. Up there, 5 more. We're just gonna go up to 100, and you'll see how many positions and rotations that actually is. It's quite a few. Since I said it was 13 each, you just multiply by 100. That's going to be 1,300 by the time we ramp all the way up to our target number. We're at 85, and once we get there, I'm going to kind of fly around each one and show you that we are, in fact, good to go. So we're at 100 now. They just spawn them randomly, and I'm going to show you the code here too so that you know what we did to achieve this from an end user perspective. It's not a whole lot, and every single one of these dudes is just doing their thing. The ones that I own on this particular client here, I'm actually manipulating them and moving them, and then everybody else, the client and the server, the other ones, they're just getting updates via GONet. But right now we have 100 characters, each with 13 synced positions and rotations, for a total of 1,300 on each one of those that are being synced. That is pretty large scale. That is way better than just being able to do 8. This can go higher, and I'm glad to take this even further, but I'm going to go into the other client and show you it's the same thing. And you can verify all this stuff in code. It's really pretty cool. I'm excited we're able to achieve this, because now I think we're going to be able to help that team out to achieve their scale that they want. Because, you know, if your game is designed to work with 100 people, then dang it, you need a technology that's going to get you there. And this is the server over here. And this fly cam is a little bit stupid and backwards, but I'm just flying around. So the server only owns 5 of these things, and the other 95 are owned by those 2 clients. But we're all in the same simulation. All the movement is occurring. You can see that on my non-gamer PC, it's okay. It's got some okay specs. It's able to run all this, server and 2 clients, without, you know, poo-poo in the bed. So I think this is pretty promising results. And I think what we're going to do now is I'm going to go into the code and show you what it took to achieve this. And I'm just going to leave these guys running in the background as I go back to here. All right, so as always, so this is the scene. There's really not much to it. You've got your UI for all this stuff up here. That's really not all that important. What is important is the GONet global context, as always. That's why I put it on 250 millisecond delay that's baked in. I should have put it down to 150, but basically this is just the prefab. You drag it from here and you put it in your scene, every single GONet scene you want to do. So that's the main thing. Then I've got a character spawner that spawns and basically does most of what we're doing here. So let's go take a look at the character spawner. But just want to point out that you know, you have to tell it what character you want to spawn. We'll look at that in just a minute. What is the spawn area radius like? So how much area do we randomly want to take up as we spawn these things, and how many do you want to spawn every time you hit the space bar? So currently we had it set to 5, like I said. And then you got some UI stuff that's being set up here. So that's fairly straightforward. So let's just take a look. So this character spawner is a GONet behavior. And because we want to link into some of the GONet events and lifecycle methods, this one is the one that we wanted. So as soon as GONet is aware whether or not this particular runtime is a client or a server, that's the first time in the simulation that it's okay and kind of safe to start spawning things and instantiating GONet participants. So if it is the server, then we want to go ahead and spawn those 5 to get started with. And spawning those 5 is very straightforward, very simple. There's really not any magic going on here. You're just calling the object.instantiate, just like any other Unity instantiate that you've ever done, but GONet makes it auto-magical, and it does it across the network, so everybody else who's connected gets those as well. Even as you saw, people who connect after the fact, they also get these instantiated. You saw that when the clients connected, they got the 5 that the server made. You tell it what you want to spawn, and in this case it's a GONet participant. And then I just randomly, within that spawn radius, choose where we want to go, and we randomly rotate him on the Y so that he's facing in whatever direction. So, this is all just further evidence that it's very easy. It's very, very similar to what anybody would be used to who's used Unity before. So, the next kind of thing that we did, which this is really not that important, but I did want to show you that this is another method that you can override whenever you extend GONet behavior. You can override this and you can override this, so that every time a GONet participant is added into your scene, this will get called, and then you can do some stuff after the fact. So what I did was I said, and I added a tag to our character. We'll see what that is. But every time a GONet participant is added, if it has this multi-part character tag, I want to do some maintenance on keeping track of those numbers that we display up here in the UI, right? So that's what all that is, right? So every time I get one, we spawn them, and then we multiply by 13 to figure out how many positions and rotations are actually being synced by GONet, and I'll show you why we chose 13 here in a moment. Then in the update, like I said, you can do Alt and then spacebar, and you can spawn more. Now you notice there is no is server guarding here or is client. Like I could do any amount of spawns on any of the clients or the server just by pressing Alt space. I chose only to spawn them additionally from the clients, but you can see that's how it occurs. It's very easy. Did some little calculations here on the frames per second. And then I logged out some stuff that's really not important, but you can get some usage statistics printed out to the GONet log if you want. If the frame rate were to go below 20, I wanted to look at that. So that's really not important. That's all there is to the character spawner. That is very simple. And the next thing I wanted to point out was the multi-part character, right? So if you like, that's the character it's going to spawn. So let's click on that and let's open that prefab. So right off the bat, you can see that it has a GONet participant on it and that the position is synced and the rotation is synced. And so now I'm going to get into some of the nitty-gritty into how you can deal with synchronizing transform information off of any of the children of a GONet participant, because this is important. Ding, ding, ding. GONet does not support a GONet participant having other GONet participants under it. So how in the world are we actually going to get the position sync and the rotation sync on the children? That is the question. So this was something that I've done before, but not nearly to this extent. So I'm just going to quickly show you where we got the number 13 from before I go any further. So here's one. So we know this is one position and one rotation. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So there's 13 transforms, 13 unique positions, and 13 unique rotations that can be synced, and I will show you how we actually do sync them. One of them you know for sure, right off the bat, is position synced, is rotation synced. That's one. You know how that works, or at least you can trust that GONet has a method for that. Now the other ones, I just wanted to quickly show you, if you didn't notice, these do not have GONet participant. There's nothing special on them at all that links them to GONet other than the fact that their parent is a GONet participant. So let us take a look at this script right here. Multi-part character. These are all just some public fields like you would have on any mono behavior. And so this stuff that gets rendered out here is your default behavior. So this is a vector 3 and this is a quaternion. Okay, so these are all the things that are public on this multi-part character. So let's take a look at that. All right, so multi-part character. This is a GONet participant companion behavior, which if you're familiar with that, it has to be installed. GONet participant companion behavior has to have a sibling that is a GONet participant. So this guy will get a reference to this GONet participant by default as long as it's installed at the same level on that game object. So that's what we did. And I just wanted to show you real quick that, so pelvis position, pelvis rotation, that's the first two right here. It's going to go in order just like any other mono behavior on these public fields. So pelvis position, pelvis rotation. You can see that right here. Pelvis position, pelvis rotation. And they're public vector 3 and a quaternion. So the thing that you may not have used, we haven't really talked much about in any other video, but GONet Auto Magical Sync. That is very similar to the UNet Sync var. So you simply put this attribute right next to it, and now automatically any changes to this will get networked across to the non-owners. And that's the way we achieve dealing with synchronizing all of these children when in fact they do not have a GONet participant on them. They're just regular old things. So I'm not going to go too far into how that works. Maybe we will. I know we will in a later video, but for now, just know that you add this, automatic synchronization is going to occur. I will point out just a little bit, though. I've got this, and I've got comments in here, right, that explains this, and I'll probably share this with people so that they can have this project to think about and use it as a kind of starting point for more complex things and higher scale operations like this is demonstrating. But you can set a profile to use that defines the settings for synchronizing this guy right here. And the one that we chose is multi-part character parts _ position. And it tells you right here in the comment what that actually maps up to. Assets, GONet, resources, GONet, sync settings, profiles, multi-part, asset, right? So if we follow that down here, it actually goes GONet, resources, GONet, sync settings, profile. And then there it is, dot position. That's the asset. These are the settings that we are using for synchronizing the position of all these little dudes. So we have it set to synchronize every 24 hertz, which is 24 times per second. See? And it's unreliable. And we blend between the values. So you're only going to send out at 24 frames a second, but every single frame of the simulation, you want a good value on the people on the other side of the network. So if I don't own it, I still want to see smooth animation. And that's what this value blending across the values received indicates. And here's where I'm not going to spend too much information or spend too much time talking about what's going on here. You can read this. I'm going to go on a deeper dive later. But this quantized down to bit count and lower and upper bound for quantization is extremely important. This is basically going to say that every single component of that vector 3, so the X, the Y, and the Z, will each get quantized down to 13 bits, which is quite a bit smaller than 32-bit floats, because a vector 3 by default, each one of those components is a float 32-bit. So now it's going to be quantized down and made smaller down to 13 bits each. So an entire vector 3 would be 39 bits, which is just 3 bits over, or I'm sorry, 6 bits over the 32. Actually, arithmetic is not so great right now, but it's 32 bits per, and now I'm doing all 3 in 39, which is pretty cool. But there's some tricks and reasons why that's important. But I have to tell it down here in this little area to use the value type. For vector 3s, we have a custom serializer within GONet that will serialize these things and deal with the quantization, and it knows how to do that stuff. The same thing for the rotation, but the rotation is also at 24, unreliable and value blend. And it's a quaternion, and it's a quaternion serializer, right? So those are the important things. Whenever you have this quantized down to 0, that means it's not going to be quantized. However, like I said, I'll get into more details in another video, but however, in this particular case, this quaternion serializer inside GONet, it actually is going to use some tricks. It's going to quantize it down. So this is a little bit of a misnomer, but just FYI. So that's what all these are. These are simply here because GONet does not support the nested GONet participants. So we needed some sort of way to synchronize these. But there's really nothing in here that links this to
the pelvis, right? So it says pelvis position, pelvis rotation, but that does not, there's no linking. I didn't drag this pelvis over there or anything like that. So I want to show you, like I said, I didn't want to spend too much time on all this, but I will show you kind of quickly how we do it. In the transform, when we wake up, we find the pelvis, so that gives us the pelvis. We find the neck, that gives us the neck. So these are some of the details of how we achieved synchronizing all these children, position, rotation. Another trick is that we're using local position instead of the global position, because you know that you're in a smaller range. You got to do tricks of the trade to get things down as small as you can. And local position in this case, because they're children and they're only so far away from each other or the root, that you know that the local position is going to be within a certain small range. No matter where I put this, I can put the root anywhere in the world, and these children are still going to be in a small range for the position compared to what they could be around the world for this one. And that one's synchronized this way. So just trying to talk about some of the differences. Let's go back here. So we go grab all the transforms, and then I created this little class right here, a single part manipulator. Basically, this is what does all the random movements, okay? And I'll show you that down here. So all those random movements, they occur in the update. So this is very much what is driving all of that random motion that's occurring over here. All these dudes, all these pieces, all these parts are translating and rotating every single frame if they're the owner. So let's take a look at that. So I created a method called manipulate part. It takes that instance of the manipulator, it takes the transform, and then the position rotation as references. And I'm not going to spend too much time talking about that, but what I wanted to show you is the following. So if that GONet participant that this multi-part character is installed on is mine, then I want to make the changes. I want to manipulate the transform of that thing. And after I'm done manipulating it, then I have to update those references. It's a little bit deep. I'm hoping this doesn't get too deep for you. But if you are, well versed in this type of stuff, hopefully you'll figure it out. The big thing to understand here, though, is I'm only manipulating this in the update loop if it's mine. So everybody else is not going to actually directly be rotating and doing this stuff. What's actually going to happen is we're going to take the local position and rotation and update it to what was calculated for us. So as you can see, if it's mine, I do the manipulation and then I update the transform directly. But if it's not mine, this GONet sync position and rotation is actually going to be one of these guys. It's going to be these. And these are going to automatically be updated, automatically I should call it, because it's GONet automagical sync. These get updated from the owner automatically via GONet because of this. So on the non-owners, these values are going to get updated. And they're going to value blend between. And that result of those value blendings, we need to apply to the transform of each one of those bones to the local position and rotation. So this is going to happen for the non-owners. It's going to happen for the owners as well right after they manipulate it. But for the non-owners, the actual value changes are coming from GONet automagical sync. Okay? So every single one is updated, and then the root bone, this is the root. This one's handled slightly differently, but it's all very much the same. And that's the entirety of what we did here. All these guys are public and they're automatically synced from the owner to the non-owners via our usage of this attribute, because GONet does not support nested GONet participants. These do not have GONet participants, only this guy. So that's how this all works. Let's go back to the server. See, he's still rocking steady. We got 1,300 positions and 1,300 rotations being synced, and he's still rocking out at 60 frames a second. Let's open up our other client. He's still got them all. Everybody's doing their thing. Everybody's moving around. This is 100 characters, 13 components each for each character, giving us a grand total of 1,300 positions and 1,300 rotations at 100 characters, all running locally. And where's my CPU stuff at? On a halfway decent CPU, I guess, all on the same one. So this is a pretty good proof of concept. I hope it helps you understand the scale that you can achieve and how you get some of those details of multi-part characters, kind of like this. So I'm pretty excited. I hope that team continues to work with GONet, because I think it's going to be in their best interest. And I'm really looking forward to the great things you guys do. And until next time, keep on keeping on. Have a good one.